So today we're going to dive into something called Composer 2. It's a new AI model that's been designed to go way beyond just spitting out lines of code. It's actually built to handle the messy, complex, real-world job of a professional software engineer. A world that, honestly, most AIs just aren't prepared for. Let's see how they pulled it off.
We've all seen AIs generate little code snippets, right? But that's a whole different universe from what a human developer actually does. Real engineering isn't about solving neat little puzzles with perfect instructions. No, it's about navigating ambiguity, untangling massive code bases, and making really complex changes. So, the big question is, can an AI actually step up and fill that role for real?
To even begin to answer that, we first have to understand the core problem. And it turns out, the way we've been testing coding AIs is often totally disconnected from the daily grind of a developer.
Yeah, a lot of the public benchmarks out there give an AI this super detailed, hand-holding prompt to fix one tiny, isolated bug. But in the real world, a bug report might just be one sentence from a user, and the fix could mean changing hundreds of lines of code across a dozen different files. It's a classic case of what researchers call prompt overspecification, and it just doesn't capture the real challenge at all.
Okay, so these two charts right here just perfectly show the massive gap we're talking about. Look at the one on the left. See how public benchmarks have these incredibly long, detailed descriptions? Now, look at the chart on the right. For all that text, they only require tiny little code changes, a median of about 10 lines. CursorBench completely flips that script. The descriptions are short, kind of vague, but the fix, it's huge, averaging 352 lines of code. That is what the job actually looks like.
So here's the bottom line. We need a much better way to measure an AI's coding chops. And that's exactly where CursorBench comes in. It's built from actual tasks that human engineers did, with all the ambiguous requests and large multi-file changes that come with it. It is a much, much tougher and way more realistic test.
Okay, so if you've got this much harder test, you're going to need a much smarter student, right? Well, meet Composer 2, a model that's been specifically trained to crush these complex real-world problems. But how in the world do you train an AI to think like a seasoned developer? Well, it's a two-phase process, and you can think of it like this. Phase 1, continued pre-training, is like the AI binge-reading every single programming textbook, all the documentation, and every open-source project it can get its hands on. Then Phase 2, reinforcement learning, is like throwing that AI into a really tough residency program, where it has to solve real problems day after day.
So this first phase is all about building a rock-solid foundation. They take an already powerful model, in this case Kimi K2.5, and just completely immerse it in code. The goal here isn't to solve specific tasks yet, it's about making its fundamental understanding of programming languages and patterns as deep as possible. This is where it gets its book smarts.
And then comes the on-the-job training. In the reinforcement learning phase, the model isn't just reading anymore, it's doing. It gets fed real tasks from CursorBench and has to try to solve them. When it does a good job, it gets a reward, which reinforces that successful strategy. This is where it learns the tricky stuff, reasoning, planning, and how to handle those long, messy problems.
So what's the secret sauce here? I mean, how do you make this training actually effective? Well, it all comes down to making that residency program feel as close to the real world as possible.
And they've really gone all out to make it realistic. First off, the AI trains in the exact same software environment it will eventually be used in, so there are no surprises when it goes live. Second, the tasks aren't just simple bug fixes, it's the whole shebang, refactoring, writing tests, building new features. And finally, get this, it's not just about getting the right answer. The model actually gets rewarded for writing clean code and using its tools efficiently, just like you'd expect from a senior engineer.
They even baked in this really clever incentive to shape its behavior. It's called a nonlinear length penalty. Just look at this curve. It shows how the cost or penalty for taking more steps to solve a problem changes. See how it's super steep at the beginning, but then it flattens out?
Yeah, the quote on the slide absolutely nails it. The system basically penalizes the AI for taking too long on easy tasks, which pushes it to be fast and efficient. But for a really gnarly, complex problem, that penalty flattens way out, giving it all the room it needs to think things through. It's how the AI learns to balance speed with depth.
All right, so all this intense, reality-based training, does it actually pay off? Let's get to the results and see for ourselves. On CursorBench, the test of real-world software engineering, the results are, well, they're fantastic. Composer 2, that orange bar, scores a 61.3%. That is a massive 37% relative improvement over the previous version, and it's right up there competing with the biggest, most powerful models out there.
But here's the real kicker. It's not just about raw performance, it's about efficiency. Look at this chart on the right. That little red dot for Composer 2 is delivering top-tier results, but at a fraction of the cost of its rivals. This is what you call a Pareto optimal trade-off. It just hits that perfect sweet spot of power and efficiency.
So what does this all mean when you put it together? Composer 2 pretty much proves that by shifting our focus away from simple abstract tests and instead training AIs for the messy reality of the real world, we don't just get better performance, but we get models that are both way more capable and way more cost-effective. The question is no longer just, can an AI write code, but maybe, how soon until a super specialized AI like this becomes an essential member of every single engineering team?